9.2. This is 9.2. It's a rule of thumb when considering whether or not to apply the central limit theorem to a drawn to a sample drawn from a population that is not normal with sample size considered large, 25 or more. Which of the following is not a condition that must be checked before applying the central limit theorem? The samples must be drawn from a population that is normal. What is the mean of the sampling distribution of the sample mean? The population mean. When computing a t-statistic, one divides the estimate by an estimate of the standard error. Why don't you divide by the standard error? Because in real life, one knows, almost never knows the population standard deviation. So in real life, you don't really know the spread of the data, population spread. In the t-distribution, the degrees of freedom refer to which of the following? The sample size. Degrees of freedom is equal to n minus 1. Let's look at one like it. The average income of a certain region in 2013 was 81,000 per person. Standard deviation was 25,000, and the distribution is right skewed. Suppose you take a random set of 100 residents in the region. Is the sample size large enough? Central limit theorem for means. Explain. One of the conditions is that the population is normal or the sample size is large. As a rule of thumb, 25 is be considered large, so the sample size is large. So from there, you can use it's large enough to use the central limit theorem. B, what are the mean and standard error? So for this one here, uh, the mean and standard error is going to be found by this here. It's standard deviation divided by n. So the standard error is going to be standard deviation divided by n. Okay. So to give us the standard deviation of 25,000, and the number in the n is going to be 100. And there's our standard error, 2,500. C, what's the probability that will be more than 2,500 away from the population mean? So to find the probability here, that the value that is 25 below the mean is above the mean. So it could be 78, 81,000 below, 785, 81,000 above, 8350, 500. Okay. So the probability that it's going to be less than 78,000 is 15.1587, and it's greater than 0.835. It's going to be 0.57. So that is more than and less than here. You add those two probabilities together. Therefore, the probability that sample will be more than 2,500 away from the population mean is 0.3174. Look at these again. Define these here. Let's see here. Yeah, they gave us an example. So looking at this here, the mean age of all is 7.1. That's a characteristic of the population. That's a parameter. So that is power deviation for all cars. So that's a parameter. The mean age of 60 cars randomly selected is 7.6. That's a statistic. So standard deviation from a sample of randomly selected, that's going to be a statistic. So describe them. Population mean is 7.1. Population standard deviation is 6.8. S is the sample standard deviation, and X bar is the X mean. The conditions for the limit theorem fulfilled. Randomly select cars. Okay, since find the age. Okay, find the age of one car that's going to affect the ages of the car. They're independent of each other. Uh, so it's not normal because it says it's right skewed. Check the sample size. 25 is long enough. Yes, so simplify that. So yes, it does fit. Okay. Number 8. Describe here. You have your population mean, population standard deviation, sample mean, and sample standard deviation here. The value of mu is a parameter. It's found in population. Size of the sample. No, central limit theorem does not fit because sample size is too small. What were the shape of the approximate sample distribution of any means? Each from a sample of 5 students. It would be right skewed here with the shape. Yeah. It'll conform to the population here, which is right skewed.